This lesson is on solving division word problems. Now it's going to be important that you pay careful attention to the question and exactly what it's asking, and you'll need to make sure that you break it down into smaller pieces. If you try to solve the problem in 1 or 2 steps, it's going to be overwhelming and you're going to have a really hard time with it. I'd also strongly suggest that you draw a picture every time you want to solve these problems. So let's get started. Ava is saving for a new computer that costs $1,218. She already saved half of the money. She earns $14 per hour. How many hours must she work to save the rest of the money? Now we know how much it costs total, and we can find out how much she has, how much she needs, and then we'll look at it from there. So for my image, I drew a simple box chart. And I have the total amount that she needs for the computer, which is $1,218. This part on the inside is divided in 2 because I know that she saved half, which is represented on the left here, and that she needs the other half, which is on the right side here. So we're splitting it in 2 pieces, which means my first step is going to be dividing it by 2. Okay, so I'm looking for this amount here, and then what I'm going to do is I'm going to take that same amount and bring it over to the other side because it's half, it's the same, and then I'm going to divide it by 14 because she makes $14 per hour, and that will give me how many hours she needs to work. So let's go ahead and solve it. Again, we're going to start with 1,218 divided by 2. And you already know how to do that. Okay? We're going to set it up the division problem. 1,218 divided by 2. And I know that 2 times 6 is 12. Bring down the 1. 2 does not go into 1, so I'm going to write my 0. Bring down the 8. 2 goes into 18 9 times. So 600, and this is 18 times with 0 left. So 609 is half. Now I'm going to use that to get my next step. And we're going to slide this to the side here. Okay, so we know that she has saved $609 and that she needs 609 more. And we're going to remember that for those $609, she gets $14 per hour. Okay, so we're going to divide 609 by 14. Now I know that 15 times 4 is 60, so I'm going to work in the ballpark. And I'm going to put 4 here. And 14 times 4 is 56. Okay, 60 minus 56 is 4. Bring down the 9. 14 goes into 49 3 times. Okay, 14 times 3 is 42. And I'm running out of space, so I'm going to slide it up. Okay, and I have 7 left. I'm not going to write remainder 7. What I'm going to do is I'm going to put in that decimal again, don't forget it, and remember that I have 0 tenths, and I'm going to slide that down. Now 14 can go into 70 5 times, and 14 times 5 is 70. So I know that she needs to work 43.5 hours to get $609, assuming no tax or other expenses. Okay, let's look at another problem. Gavin has a collection of 1,404 sports cards. He wants to sell them in packs of 36 cards and make $633.75 once they're all sold. If each pack is the same price, how much should he charge per pack? Now I'm going to look at this and say, before he sells any of the packs, he wants to split the total number of cards into the packs. So I know my first step is going to be dividing. Okay, and I'm going to draw an image to go with this again. In my image, what I did is I have the same setup as last time. I have 1,404 cards total. Okay, and what I've done here is I've illustrated that in one pack there are 36 cards. So I only drew 2 packs, and I need to find out how many more packs there are. Okay, I also wrote the price here, that he wants this much money for this many cards, and that we're looking for this price here for 1 pack. You don't need that right away, but it's going to be helpful later on. So we're going to put that to the side, and the first step is going to be dividing 1,404 by 36, because that's how many cards divided by how many cards in a pack. Okay, again, you know how to do this part. 1,404 divided by 36. And when I solve that, I know that 36 does not go into 1 or 14, but it does go into 140 3 times, which gives me 108. Okay, when I subtract it down, 320, bring down the 4. Okay, and 36 times 9 gets me 324. So I know that there are going to be 39 packs. My next step from there is going to be splitting the price over those 39 packs. Now remember, he wants to make $633.75 from those 39 packs. So it's $633.75 divided by 39. And let's quickly walk through the division. Okay, 39 does not go into 6 evenly. Okay, 39 does go into 63 once. Okay, when I subtract that down, I have 24. Bring down my 3. So I have 243, which goes in 6 times. Also notice I forgot to bring in my decimal, so add that in, please. Okay, 243, 39 times 6 is 234. Which when I subtract that, it gives me 9. Bring down the 7. Okay, 39 into 97 goes twice, which gives me 78. Then I'll make it smaller again. Okay, 39 minus 78 gives me 19. Bring down the 5. Okay, 39 into 195 goes 5 times. Okay, 195 and 0. So for each pack, he's going to sell it for $16.25. Now some of you might ask where I got these numbers from. Okay, remember I'm using my schema, what I already know, or I'm going to estimate, and I can solve it on the side to see how many times each number goes in. Let's look at another problem. Olivia is building a tree house. She cut 12 pieces of wood from a board that is 128 inches long. 5 of those pieces that she cut were 15 inches and 75/100ths of an inch. And 7 pieces were evenly cut from what was left of that same board. Okay, she calculated the width of the saw blade will cause her to lose 2 inches of wood after the cuts. What is the length of each of the 7 pieces? It sounds a lot more complicated than it is, but there are multiple steps, and remember we're going to draw a picture to walk us through it. Let me show you my picture. Okay, I have drawn one board here. And what I did is I took my 2 inches off right away, because that's what's going to be left. I'm losing 2 inches. Okay, And I know that she cut 5 pieces that were 15 inches and 75 hundredths. So I have those 5 pieces right here. What I'm looking for is this length here. Okay? So the first thing I'm going to do is find out the lengths that I already have. Okay? And to do that, I'm going to start with 128 inches minus 2 for that piece that came off, which gives me 126, minus the 5 pieces that are 15 inches and 75 hundredths of an inch. Now, when I solve that, I find that it is 78 inches and 75 hundredths of an inch. So when I subtract it, what is left is 47 and 25 hundredths. And that's going to be divided into my next piece, which is these 7 boards here. Okay, so let's move this to the side. Oops, multiple pieces. Okay, so what I have now is I'm going to divide my remaining length, which is 47 and 25 hundredths, bringing up that decimal right away, by my 7 pieces. Okay, using the multiplication facts that I already know, 7 times 6 is 42, okay, which gives me 5. Bring down the 2. 7 times 7 is 49. Okay, 52 minus 49 is 3. Bring down the 5. 7 into 35 goes 5 times. Okay, with nothing left. So I know that each of those 7 pieces is 6 inches and 75 hundredths of an inch. To check this problem, I could multiply each board, that is 6 inches and 75 hundredths times 7, which will give me this section. I can then add that to the 47 and 25 hundredths and the 2 inches, and I should get 128 inches as my final sum. And that tells me that I did it correctly. Let's try one last problem. A load of bricks is twice as heavy as a load of sticks. A total weight of 4 loads of bricks and 4 loads of sticks is 771 kilograms. What is the total weight of 1 load of bricks and 3 loads of sticks? Draw an image and try to solve it on your own. When I did it, I wanted to remember that the bricks are twice as heavy as the sticks. So what I did is I drew 1 unit of bricks, which is the same as 2 units or 2 loads of sticks. Okay, and that's going to be important. My next step is I broke it down farther. I drew out equivalent weights. So here I have 2 containers for the bricks, showing that it weighs twice as much as the sticks. Another way to look at it is that each of the squares here is a pound. So let's say that 1 load of bricks is 2 pounds, then 1 load of sticks is 1 pound. Okay, it's twice as many. And when I break it into units like this, I have 1, 2, 3, 4 loads of bricks, and 1, 2, 3, 4 loads of sticks, which gives me 12 units total. 8 for the bricks and 4 for the sticks. And then what I'm going to do is I'm going to say that I have 771 kilograms divided by 12 different units. Remember my units here from the last slide. Okay? And again, you know how to divide 771 by 12 on your own. Okay? And when I solved that, I found that each unit is 64 and 25 hundredths of a kilogram. Okay, that's for 1 unit. 1 unit is the same as 1 load of sticks. So if I slide this to the side, I know that I have 3 loads of sticks, so I'm going to do 3 times 64.25. And I know that I'm going to have 1 load of bricks, which is twice as much as 1 load of sticks. So I'm going to do 2 times 64.25. Now looking at this, I know that it's the same number, 64.25, times other numbers, so I can simplify this to say 64.25 times 5. Okay, I got 5 because of the 2 and the 3, and I'm adding that together. And then I can solve it. And when I solve that, I find that I have 321 kilograms and 25 hundredths of a kilogram. Okay? Again, we're just breaking the problems down into smaller pieces that are much more manageable. If you have questions, be sure to ask.